So good morning, good afternoon and good evening friends. So in the previous video we had seen about the maximum safe speed, then banking of angles, and we had taken the short introduction about the speed limits. Now we are going to see the detailed about the speed limits. So speed limits जो है वो दो parts में उन्होंने divide किए हैं. That is the first one lower speed limit and the second one is upper speed limit. So let's see about the lower speed limit first. The first one is lower speed limit. Let's have a short recap about the previous lecture before going to further one. That is the maximum safe speed. We had calculated the formula. That is V is equals to under root RG tan theta. अभी यहाँ पे ध्यान में रखने वाली बात क्या होती है कि इस केस में हमने फ्रिक्शन को निगलेक्ट किया था. We had not taken the μs and fs. So coefficient of static friction and force of static friction को हमने कंसिडरेशन में नहीं लिया था क्योंकि हमने यहाँ पे μs की वैल्यू 0 कंसिडर की थी for uniform roads, and in this case we are going to take force into consideration. That is μs we are going to take. So μs की वैल्यू यहाँ हमें मैटर करेगी. In this case we have taken the value of μs as 0. अभी लोअर स्पीड लिमिट के बारे में सीखेंगे. यहाँ हमें फ्रिक्शन को कंसिडर करना है. पिछले केस में फ्रिक्शन को हमने कंसिडर नहीं किया था. अगर व्हीकल v इज इक्वल टू आर जी टैन थीटा, अंडर रूट आर जी टैन थीटा के स्पीड्स एग्जैक्ट सेम स्पीड से अगर चल रही है तो व्हाट आर द फोर्सेस एक्टिंग ऑन द व्हीकल? वी हैड सीन इन द अर्लियर लेक्चर. दैट इज द वेट एक्टिंग वर्टिकली डाउनवर्ड्स. And second one, that is the force. That is the normal reaction. Normal reaction acting perpendicular to the road. So this was our diagram. The car traveling on a curved horizontal road, and the forces acting on it were mg vertically downwards, and this was a normal reaction perpendicular to the road. So we had resolved this normal reaction into two components. The first one is along theta, that is n cos theta, and the second one is n sin theta, away from theta. अभी लोअर स्पीड लिमिट की बात कर रहे हैं तो यहाँ पे फ्रिक्शन की बात आएगी. तो फ्रिक्शन को समझते हैं. अभी लोअर स्पीड लिमिट में क्या होता है, फ्रिक्शन जो है वो रोड के इंक्लिनेशन के अवे लगता है. फ्रिक्शन इज अप्लाइड अवे फ्रॉम द इंक्लिनेशन ऑफ द रोड. अभी ये जो है ये इंक्लिनेशन है, तो इंक्लिनेशन यहाँ आ रहा है एट द सेंटर ऑफ द ट्रैक. इंक्लिनेशन इज टुवर्ड द सेंटर ऑफ द ट्रैक. समझने की कोशिश कीजिए. So friction will be directed opposite to it. ये inclination है toward the center, and जो force है वो force it will be directed away from the center, that is opposite to it. So ये जो है this will be our force. अभी जो ये थीटा है तो थीटा का corresponding angle this will be also theta. So this will be f cos theta if we resolve this, and the upper one will be f sin theta. Understand? The horizontal component will be f cos theta and the vertical component will be f sin theta. Now, if we resolve all these components and if we balance the components, so एक बात है, हमने centripetal force को balance नहीं किया अभी तक. Centripetal force will be directed away from the center, that is mv square by r. If we balance all these forces, we get two equations. The first one is vertical, along vertical direction, So along vertical direction, this one is, first one is n cos theta along the vertical direction going in upward, and the second one is f sin theta. The third one is mg, that is acting in the vertical downward direction. So अब ये तीन फोर्स है n cos theta, f sin theta and mg. अभी n cos theta and f sin theta ये mg को बैलेंस कर रहा है. So the equation will be like this: n cos theta plus f sin theta is equals to mg. क्योंकि क्या हो रहा है, n cos theta plus f sin theta ये mg को बैलेंस कर रहा है. So the equation will be like this: ये दोनों फोर्स it is balancing mg along vertical direction, and if you talk about the horizontal direction, so the horizontal forces की बात करें, the first one is n sin theta, the second one is f cos theta, and the third one is mv square by r. So these three forces we have to balance each other. अभी यहाँ हमें साफ साफ दिख रहा है कि f cos theta plus mv square by r ये किसको बैलेंस कर रहा है, n sin theta को. So the equation will be like this: n sin theta is balancing f cos theta plus mv square by r. So f cos theta को अगर हम लेफ्ट हैंड साइड शिफ्ट करें, the equation will be like this: n sin theta minus f cos theta is equals to mv square by r. So we got two equations. Name it as equation number 1 and equation number 2. अभी इसी दो इक्वेशन पर हम फर्दर ऑपरेशंस करेंगे टू फाइंड मिनिमम स्पीड. अब मिनिमम सेफ स्पीड कैलकुलेट करने के लिए these equations are useful. In the previous lecture the maximum space speed we had calculated, पर वहाँ हमने फ्रिक्शन का केस कंसिडर नहीं किया था. इस केस में हम फ्रिक्शन को कंसिडर कर रहे हैं. That is why we are finding the minimum speed for lower speed limit and the maximum speed for upper speed limit. अभी क्या करना है, we will divide both these equations by cos theta. Divide equation 3 and 4 by cos theta. So what we will get, first the first one is n plus cos theta will get cancelled, plus f tan theta, that is sin theta upon cos theta is equal to tan theta, and mg by cos theta. So name it as equation number 3rd, and the second one is n sin theta minus f cos theta is equal to mv square by r. So n sin theta upon cos theta will be tan theta minus f is equals to mv square by r cos theta. So name it as equation number 4. Got it? अभी हम क्या करेंगे, we will divide equation number 4 by 3rd. ध्यान दीजिए, ये डेरिवेशन जो है, ये डेरिवेशन इज मोर यूजफुल बिकॉज जो कंसेप्ट हम यूज कर रहे हैं यहाँ पे, this will be useful for finding the problems or finding the solutions in your CET examination. Understand the logic behind this derivation. So divide equation 3rd, divide equation 4th by 3rd. What we will get, the first one is n tan theta minus f upon n plus f tan theta is equals to, now cos will get cancelled, m will get cancelled, so what will be remaining, v square by rg. Understand? अभी हमारा मेन मोटिव क्या है, we have to find v, so we will shift all the terms at the left hand side. So rg will come here, Rg in bracket n tan theta minus f upon n plus f tan theta is equal to v square. Got it? So ये हमें इक्वेशन मिल गया. Just we have to take the square root on both sides. We will get the equation for v. So v is equals to, taking square root on both sides, so v is equals to under root Rg upon n tan theta minus f upon n plus f tan theta. ओके, अभी आप बोलोगे कि बुक में फॉर्मूला अलग दिया है, यहाँ फॉर्मूला अलग है. सो वी नो दैट F is equals to mu s into n. This is the force for static friction, and we had studied in the 11th standard that force of static friction is equal to mu s into n. That is, F is equals to mu s into n. So we will put the value of F in this equation. What will we get? Rg into n tan theta minus mu s into n upon n plus mu s into n tan theta. अभी यहाँ पे साफ साफ दिख रहा है n n n n. अगर हम इसे कॉमन निकालेंगे, the n will get cancelled. What will remain? Rg into tan theta minus mu s upon 1 plus mu s tan theta. We got our final answer, that is V minimum is equals to under root Rg tan theta, Rg into tan theta minus mu s upon 1 plus mu s tan theta. So this is the formula for finding the minimum speed considering the case of friction. Now we will move towards the upper speed limit. The same concept will be used for upper speed limit. The slight difference is that we had considered the friction in the first case, that is away from the inclination of the road, and in this case upper speed limit we are going to consider the friction along the inclination of the road, that is toward the center of the track. Let's understand diagrammatically. The second case is upper speed limit. Upper speed limit. Now here it is theta. This is the car traveling along a horizontal road, and the weight acting in downward direction, the normal reaction perpendicular to the road. This is n cos theta. This is n sin theta. Now हमने क्या कहा था कि फर्स्ट केस में हमने फ्रिक्शन जो कंसिडर किया था, it was like this, that is away from the inclination of the road. Now for upper speed limit, that is for maximum speed, we are going to consider the friction towards the center of the track, that is to along the inclination of the road. So ये theta है. What will be the alternate angle? This theta. अभी ये जो है ये F, ये arrow मैंने toward the center of the track दिखाया है, that is the friction is along this. So friction is along this. What will be the component? This will be F cos theta, and away from the component, that is F sin theta. understand the forces. The first one is along the vertical direction. The first one is n cos theta. The second one is mg, and the third one is f sin theta. So along vertical direction, first one along vertical direction. What was that? The first one is n cos theta, second one is f sin theta and mg. So समझने की कोशिश कीजिए यहाँ पे n cos theta or f sin theta and mg. So these two forces are balancing n cos theta. ध्यान दीजिए यहाँ पे f sin theta और mg जो है वो n cos theta को बैलेंस कर रहा है. मीन्स ये दोनों फोर्स ये अकेले फोर्स को बैलेंस करे. So what will be the equation? f sin theta plus mg is equals to n cos theta. आपको अगर डायरेक्ट समझ में आ गया तो डायरेक्ट भी आप इक्वेशन बना सकते हैं, लेकिन जिनको नहीं समझ में आता है they will first construct the equation like this and बाद में हम शिफ्ट करेंगे. So f sin theta हम राइट हैंड साइड में शिफ्ट करेंगे. mg is equals to n cos theta minus f sin theta. So this is our first equation along vertical direction. Name it as 1. Second one along horizontal direction. Along horizontal direction. अभी horizontal direction की बात करें तो what are the forces acting on the curved horizontal road? The first one is f cos theta. The second one is n sin theta. So n sin theta and f cos theta. These two forces are acting in the left direction, and the force which will be balanced by these two will be centripetal force, that is mv square by r. समझ में आया? अभी पिछले केस में भी हमने यही किया था कि ये जो दोनों फोर्स थे हमने उसे सेंट्रिपिटल फोर्स से इक्वेट कर दिया था. So the same thing we are doing here. That is n sin theta plus f cos theta is equals to mv square by r. Okay. ये जो दोनों फोर्स है n sin theta and f cos theta, ये दोनों इस डायरेक्शन में है और उसके अपोजिट फोर्स कौन सा है? mv square by r. So these two forces are balancing centripetal forces. So आपको क्या करना है? बेसिक थियरी है कि आप जो फोर्स लेफ्ट डायरेक्शन में दिख रहे हैं उनको ऐड कर देना है और जो फोर्स उसके अपोजिट डायरेक्शन में दिख रहा है उसको इन दोनों फोर्स से इक्वेट कर देना है. Such simple as this. So we got the two equations. Name it as equation number 2. So we got these two equations written on the board. Now we will do the same thing as the previous one we had done in the lower speed limit. We will divide these two equations by cos theta and will again divide this both the equation, that is equation divide equation 3 by equation 4, and we will get the result, that is maximum speed in case of friction. Let's do it. What we will do first? Divide equation first and second by cos theta. What we will get? First, cos theta upon cos theta cancel n. Only n will remain none. Minus f tan theta. Sin theta upon cos theta will be tan theta, and here will be mg upon cos theta. Name it as equation number 3rd. And the second equation, it will be n tan theta plus f is equals to mv square by r cos theta. Understand? Name it as equation number 4. We got these two equation. Again, what we will do? Divide equation number 4 by equation number 3. So we will get the result. Divide equation 4 by 3. We will get n tan theta plus f upon n minus f tan theta is equals to, here m will get cancelled, and again the cos theta will get cancelled. What will remain? V square by rg. The same we will do as the previous one. We will shift rg at the left hand side, as we have to find the v. So v is equals to rg into n tan theta plus f upon n minus f tan theta. Here it is v square. So taking square root on both the sides, we will get rg into n tan theta plus f upon n minus f tan theta. The same thing we will do, that we will put the value of f, that is mu s into n, so v is equals to rg into n plus n tan theta plus mu s into n upon n minus mu s into n tan theta. So if we will get common, the n will get cancelled. अगर हम कॉमन निकालना चाहे n from the numerator and denominator, n will get cancelled. So v will be, the final formula will be rg into tan theta plus mu s upon 1 minus mu s tan theta. This will be the final formula. अभी आप दोनों फॉर्मूला कंपेयर करके देखिए, अपर स्पीड लिमिट का और लोअर स्पीड लिमिट का. यू विल फाइंड अ माइनर डिफरेंस. आपको सिर्फ माइनस और प्लस साइन का डिफरेंस दिखेगा. लोअर स्पीड लिमिट में क्या था? v इज इक्वल टू अंडर रूट आर जी इंटू टैन थीटा माइनस म्यू एस अपॉन 1 प्लस म्यू एस टैन थीटा. एंड इन अपर स्पीड लिमिट हियर इट इज प्लस, हियर इट इज माइनस. सो सिर्फ माइनस और प्लस का डिफरेंस है. First one is lower speed limit. So यहाँ पे एक केस आती है कि डायरेक्टली ये सीईटी के पॉइंट ऑफ व्यू से बहुत इंपॉर्टेंट है. प्लीज नोट डाउन. यू विल फाइंड डायरेक्ट आंसर फॉर दिस. आप डायरेक्टली आंसर फाइंड कर सकते हैं. इफ म्यू एस इज ग्रेटर देन tan थीटा, व्हाट वाज आवर फॉर्मूला? v is equals to under root rg into tan theta minus mu s upon 1 plus mu s tan theta. So, अगर mu s is greater than tan theta, इस फॉर्मूला में देखिए mu s अगर tan theta से ग्रेटर हो जाता है तो डायरेक्टली वी कैन से दैट v minimum is equal to 0. So this is a necessary condition according to the CET point of view. अगर एग्जाम में आ जाए कि mu s is greater than tan theta, then what will be the output? What will be the result? You can directly say v minimum is equal to 0. The minimum speed is equal to 0. The second one is upper speed limit. Upper speed limit. What was the formula? V is equals to Rg into tan theta plus mu s upon 1 minus mu s tan theta. Now, this was minimum and this was maximum. Understand? यहाँ पे केस क्या बनती है कि if mu s is equals to cot theta. अभी आपको थोड़ा मैथ्स आना चाहिए, इसके लिए बोलने की जरूरत नहीं है. cot theta. अभी यहाँ पे अगर मैं cot theta रखूँ, if you put the value of mu s as cot theta, so cot theta and tan theta will get cancelled. What will be remain? 1 minus 1. What will be 1 minus 1? 0. And anything upon 0 will be infinity. You know that. अगर यहाँ पे 0 आ जाए, so V max will be infinity. Note that. These two conditions are more important. अगर mu s greater than tan theta, then V minimum will be 0. And if mu s is equals to cot theta, tan theta will get cancelled. 1 minus 1 0. Anything upon 0 will be infinity. So V max will be infinity. So we had finished the half of our lesson and we'll move towards the further one. देखते रहिए हमारे साथ अभी और भी वीडियोस आने वाली है. सो बनते रहिए, देखते रहिए हमारे वीडियोस एंड ऐसे ही उत्सुकता दिखाते रहिए हमारे चैनल पे. सो आज के लिए इतना ही. बाय बाय and see you in the next lecture. Thank you.